All right, I'm going to record this and post it.
This
If you,
meeting is being recorded.
whoa. All right. For example, in my math lab, you might see this question. Identify the following as an equation or an expression. If it has an equal sign, it is an equation. Okay? If it was just 5 times the quantity 2x plus y, and it ended, that is an expression. It's expressing an idea. This is an equation because this side is equal to this side. Okay? So when I multiply all of this by 5 to get rid of that 5, I have to multiply the other side by 5 to maintain equality, to keep that true. So just a little example. If I had 2 is 1 plus 1, right? And I have no reason to, right? But I multiply this side by 3, right? 3 times 2 is actually 6. And I don't multiply the other side. This is no longer true, right? So if I don't do whatever I did over here to this side, it won't maintain its equality. So it won't be true. However, if I do this to both sides, then I have 6 is 1 times 3 is 3, 1 times 3 is 3. Or 1 plus 1 is 2, 2 times 3 is 6, right? But it maintains the equality. Good. 2 equals 1 plus 1, and I want to add 5. I don't add 5 to both of them. I multiply both of them, but I'm adding 5 just to the entire side, right? So I'm multiplying the entire side by 3, but I'm not going term by term. I'm just distributing the 3. So you can like tack it on at the end, okay? So that becomes 7 equals 1 plus 1 plus 5. Everybody okay with that? So that's why if I multiply by 5 over here, I have to multiply by 5 over here. 5 divided by 5 becomes 1. So anything that's common to the top and the bottom of your fraction, you can just eliminate, okay? So now I have that original 3 times y plus 3 equals, don't forget those parentheses because we are distributing the 3, okay? Equals, and now we're distributing the 5. So you can either write it as 2y plus 6 times 5, or you can multiply it right away, okay? If I'm writing more steps than you need, you don't need to copy down all of those steps. I'm going to distribute the 3, distribute the 5. You can also put the 5 in front, doesn't matter. 3 times y is 3y. 3 times 3 is 9. 5 times 2y is 10y. 5 times 6 is what? 30? As I write 35. Scary. All right, any questions? So that's how you get rid of a fraction. Good? All right. Now I have a y on either side of the equal sign, and I have a constant on either side of the equal sign. Over here, when I had 9x minus 15 equals 10x, I just moved the 9x because it was faster than moving the 10x and then having a negative x and dividing by -1 to get the same answer, right? So it does not matter if the y's go over here or go over here. It's generally easiest to find the biggest number with the variable, the biggest variable, and move the variable that way so you don't get a negative variable. Or math teachers always move the variable to the left. So no wrong answer in this case. And the 10y is bigger than the 3y, and the 30 is bigger than the 9. So some number is going to be negative, right? I'm either going to be subtracting 10y or I'm going to be subtracting 30y. So it doesn't matter, okay? I will subtract the 10y from both sides, and I'm going to subtract the 9 from both sides, right? Because I've decided if I move the 10y, that means I'm moving all the y's over here, right? So if I've decided to move the y's over here, that means I'm going to take my constants and move them to the other side. Okay, so that's a positive 9. I'm going to subtract 9. You don't have to do this all in one step. You can do it step by step. Okay, so I knew I needed to move my 9 over here. So I subtracted, I did the opposite of adding, and I did it right on top of the below, I guess, the 30, because that's a like term. I knew my y's needed to be over there, so I subtracted 10 because that was a positive 10, and I put it under the 3y. Good. Use a calculator for this, okay? Even if you're using Desmos.com, if you go to that website and play with math tools, that's oh, sorry, I only sent it to one of you instead of everyone. So Desmos.com has math tools. So there will be small calculators, scientific calculators, and graphing calculators under math tools. And you can use that website on the exam. So I didn't know it, but some people in the class don't have calculators. Use that as your calculator. The more familiar you get with it with homework, the better it'll work for you during the exam, right? So instead of saying, what is 3 minus 10, right? Just put it in your calculator. But 10 minus 3 is 7, right? And the 10 is the bigger number, so the 7 is a negative to match the sign of the bigger number. 9 minus 9 becomes 0. Keep that equal sign. 10 minus 10y is 0. Sorry, it's 10y minus 10y is 0. 30 minus 9 is 21, right? So now I have a negative 7y equals 21. The 7y, or sorry, the y is being multiplied by a negative 7. So I'm going to divide by a negative 7. The easiest way to write that is to write it as a fraction. Now I have negative 7 divided by negative 7. They cancel each other out. Anything I do to this side, I have to do to this side. Good. So those are now canceled. I just have y is 21 divided by negative 7. A positive divided by negative will always be negative. 21 divided by 7 is what? 3. Negative 3 because it was a positive 21 and a negative 7. Any questions about that one? All right, I want to go over just a few more fraction style. Okay. So what if I had, this is not in your notes, just write this down because it's definitely going to come up on the exam. Okay. Or on the, sorry, on your homework. It won't come up on the exam. I can tell you that. I'm not going to give you hard questions on the exam. Minus 5 equals, what, 10? Good. What do we do here? It's another fraction. So here the fraction, it was everything was over 5, so we multiplied by 5, right? To maintain equality, we multiplied both sides by 5. Here, I just have a 1/3 next to my x. Well, for one, it's good to just realize that if the fraction is next to the x, that is the same as, exactly the same as putting the x on the top of the fraction. Okay, those are all the exact same value. If it was 2/3 x, it would become 2x over 3. Okay, it's just a different way to write it. So when you see the x next to the fraction, it's the same as putting the x on the numerator within the numerator of the fraction. Good. So you can write it like this, or you can think about it in your head as x over 3 minus 5 equals 10. Those are the same equation. Any questions? All right, so if I have x over 3 minus 5 equals 10, what do I do? Here, it was over, everything was over 5, right? So I multiply everything by 5. Everything over here just gets bigger, right? But here, there's only the x that's over 3, but the x is the only one you care about, right? Or you just hate fractions so much that you don't want anything over 3. That's also fine It just gives you bigger numbers. There's nothing wrong with saying I hate fractions. I'm going to get rid of them immediately, okay? So this is the same as that. Now, this is being divided by 3, so I'm going to take everything on this side, multiply it by 3. If I do it on this side, I have to do it on this side, okay? Now I have, so I'm going to go distributing it bit by bit. 3 times x over 3 is 3x over 3, right? Right now, I don't even know, Spencer. I made it up. Hold on. I like it though. Don't hold on. But I can't answer. 3 times 5 is 15. Spencer, tell me if I'm wrong. 10 times 3 is 30. Good? Okay. Now, oh, I think you solved it differently too. You might have solved it differently. Now 3x divided by 3, there's a 3 on the top, there's a 3 on the bottom, so those cancel. Or you can just see that they immediately cancel, right? So x minus 15, oh, sorry. Yeah, x, now we have x minus 15 equals 30. 30 minus 15, oh, sorry, plus 15. I'm adding 15 because I want x alone. X is now, we're subtracting 15 from x, so I need to add 15 on that side. I get 45 is x. Okay? You made me nervous. I was going too fast. All right. Or, so you can solve it this way. Or we can say, if this, you don't need to write down everything I'm writing down. This is recorded. You can go back later. If one makes more sense, just do it that way. Okay. You don't need to know every way to do something. You just need to know how to get an answer. So here, this is a fraction, but I'm like, ooh, I know I can move this 5 right now, right? I might not know what to do with the fraction, but I know that I can get rid of that 5. So x over 3 minus 5 equals 10. Add 5. Add 5. Good. Now that's gone. That's 15, and that's just still x over 3. Okay. Now it's being divided by 3, so I'm going to multiply it by 3. Multiply it by 3. Those cancel. I get x is 15 times 3 is probably 45, right? 15 plus 15 is 30, plus 15 is 45. Good? Any questions about that, about the fractions? I'm going to give you an even harder one, okay? I'm going to give you 2 more harder ones about the fractions. I know I'm really dragging out 2.1. I apologize. All right. This one is 1/3 x plus 2/3 equals negative. I was going to write 2/3 and I don't want to write that. 4/3. Good. Okay. This one, they are all over 3, right? Remember, this just becomes x over 3. I guess it's negative 4 over 3. Good. All right. You have the same denominator for all 3 parts of your equation. It's an equation because it has an equal sign. I want to get rid of the fractions. So I need to find a common denominator. The common denominator is 3, right? So I'm going to multiply everything on this side by 3. I'm going to multiply everything on this side by 3. What I get is x. We're going to distribute that 3, sorry. Plus 2 equals negative 4. Any questions? So if I want to get rid of a fraction, I multiply it, just like I did up here, by the denominator. Here the denominator was 5, so I multiplied by 5. Here it was 3, so I multiplied by 3. Here it was 3, so I multiplied by 3. It was the same problem. Oh, I just keep picking 3s, sorry. Here it was 3, so I multiplied by 3. It also happened there were 3 of them, okay? So now to finish that, I would subtract 2, x is -6. Last fraction I'm going to do, okay? It's not going to have a 3 as the denominator. I'm going to say 10x over 10x over 24. Yes, I'll do another distributed one. 10x over 24 minus 1, no, minus 1x, sorry, over 6 equals, put a 1 there. Good. All right, I'm going to come back to this. Somebody asked me to do another distributive property. Yes. Okay. Hold on. We're coming back to this. If you have got the distributive property down, you don't have to write this down. Okay. So the distributive property is just using multiplication to multiply up like a binomial times a monomial. So one thing times two different things. Good. All right. So if I had the difference between -5 plus x equals 10. Good. All right. When I move that 5, I'm just adding 5 to the whole thing, right? Ooh, even if it had 10, sorry, this is the whole example. 10 and 2. Good. There's only one plus 5, right? If I just put plus 5 on the end, it doesn't mean that I say 10 plus 5 and 2 plus 5. It just, this gets a 5 added. Good. And you get x is 17. I don't know. But when you're multiplying, so if it was 5x equals 10 plus 2, I need to, no, that doesn't work. Well, here I would need to divide by 5, right? It's a good example though. X is 10 divided by 5 is 2 plus, I would just leave it as 2/5. It's the opposite of what you're asking, but there's another example. All right. Instead, it's x over 5 equals 10 plus 2. So this is not the distributive property yet, but it shows me that I need to use the distributive property. I could combine like terms, but we're practicing the distributive property, so I'm not going to, okay? To get rid of that over 5, I'm going to multiply by 5. Just like I added 5 to all of this, it doesn't mean I'm adding 5 over and over, right? But when I multiply everything, it does mean I'm multiplying over and over. Each part of the expression needs to be multiplied by 5. This is being multiplied by 5, so I have 5x over 5, and they go away. Or I can just immediately say, that's on the top, that's on the bottom. I can erase them. X is, now I need to distribute the 5. The 5 times the 10 is 50. The 5 times the 2 is 10. I was going to write 10, but I got nervous. Good. So that's the distributive property. It's just y plus 3x, and I need to multiply them both by 2x. Okay. Another distributive property example. The 2x times the y is just 2xy. The 2x times the 3x, 2 times 3 is 6, x times x is x squared. So distributing just means I take what's outside the parentheses if I'm multiplying, and I multiply it by each part of everything inside the parentheses. Sorry, that's been blurry for so long. All right, last back to our fraction. Do you know what to do? Also ignore that 1, first of all. Poorly written. 10x over 24 minus x over 6 equals 1. What do I do? Here they were all 3, so I multiplied both sides by 3. They are not all 6s, they are not all 24s, right? But I know that I can divide 24 by 6 and get 4. So a common denominator of 24 and something over 24 and something over 6 is 24, okay? So I find the biggest number that I can divide 6 and 24 into, and I multiply it by that. So instead of multiplying by 3, I'm multiplying by 24. Good. So now I have 20. So you could do, right here, you could do 24 times 10 times x over 24. You could solve, oops, I'm sorry, you couldn't even see that. Good. And say that's 240x over 24. Or you can say, if there's a 24 on the top and there's a 24 on the bottom, and they're being multiplied with everything else, I cancel them. So the reason we did 24 is so that we could cancel out that 24. That is how I distribute it to the first one. I need to distribute that 24 to the negative x times over 6. So that's minus 24x over 6 equals 1 times 24 is just 24, right? So 24 times x divided by 6. We know that 24 divided by 6 is 4. So another way to look at that is 24 is 4 times 6. So another way to write this would be 4 times 6 times x. 4, sorry, times 6 times x over 6. Dumb. I can eliminate the 6 and it becomes 4x, right? Or I can just say 24 divided by 6 is the whole number 4. Good. So I'm going to rewrite this as 10x. There's no fraction anymore. Yes, finally least common denominator. There's no 24, so now it's just 10x minus 24 divided by 6 is 4x equals 24. So now I would combine 10 minus 4x is 6x equals 24. Divide by 6, divide by 6, x is 4. Really? So that's as challenging as it's going to get in my math lab, which is pretty challenging, right? That doesn't look easy, that one up there. But you know what to do. Find a common denominator, so something that you can divide by 6 and divide by 24 and try to find the smallest number you can divide by both 24 and 6 and multiply everything by that. Good? All right. We are still still not done. Back to page 3. Any questions? Questions on fractions? Question on decimals? They're going to show up on the homework, but nothing too difficult on the exam. I've told people that if you get through like 70% of your homework, you are ready for the exam. If you can do 70% of the homework without help, you're ready for the exam. All right, there is the possibility of encountering something that has no solution or infinite solutions. No solution, you solve an equation and the variables completely eliminate. So there are no x's, no y's, and the equation is false. It will never be true, right? No solution. This can never be true, no matter what number I put in for x, okay? Infinite solutions, the variables eliminate and your remaining equation is a true statement. So this would be always true. Good. All right. So here we have 3x minus 7 equals 3 times x plus 1. First thing I'm going to do is distribute the 3 You could just divide by 3 if this was like 3 and this was a 9, but 7 divided by 3 is not anything I want. So I'm just going to distribute it instead. Leave that side the same. 3x minus 7 is 3 times x is 3x. 3 times 1 is 3. Good. Now I'm going to move, and it doesn't matter, right? Left or right. I like math teachers like the variables on the left. So I'm going to say minus 3x to get rid of that 3x specifically. I'll put it under this 3x. Good. All right. That means I wanted to move the negative 7 over here. It's a negative 7, so I'm going to add 7, add 7. All right. 3x minus 3x eliminates. Negative 7 plus 7 eliminates. So that's just 0, right? There's nothing over here. Equals 3x minus 3x, nothing. 3 plus 7 is 10. Is that true? No. So this one we would say no solution. There is no number you can put in here and make this true. It is impossible for this to be true. There is no value of x that is good. Good enough. All right. 5x minus 5 equals 2 times x plus 1 plus 3x minus 7. I have this like sneaking suspicion from last semester that this one, I wrote it wrong, but we'll see. All right, first thing I'm going to do is distribute. 2 times x is 2x, 2 times 1 is 2. So that's 5x minus 5 equals 2x plus 2 plus 3x minus 7. So now what I would do is I would combine like terms only according to sides. So there are no like terms between 5x minus 5. 2x plus 2 plus 3x. 2x and 3x will be combined. And then the positive 2, make sure you just note the sign, the positive 2 and the negative 7 will combine. 2x and 3x become 5x. And then 2 minus 7 is negative 5 or minus 5. And we'll just bring down the 5x minus 5. Oh, I think we're okay. I did not mess it up. All right, 5x minus 5 equals 5x minus 5. If you see this, what do you think? Just kind of like look at it and say, if x was 0, what would happen? Negative 5 equals negative 5. If x was 1, what would happen? 5 minus 5 is 0. Or sorry, 5 minus 5 is 0. 5 minus 5 is 0. 0 equals 0. So if you see something like this and each side is identical, your equation is a true statement, always true, infinite solutions, all real numbers. Good. Infinite, sorry, I should note that. Infinite solutions, they might call it all real numbers. You can put any number in there and it will be true. Infinity symbol is just a side, kind of like a long sideways 8. So it's like, oh, sorry, parentheses. From negative infinity to infinity, all real numbers. All right. So is this always true no matter what value you put in for x? Yes, right? Because this side is exactly the same as this side. They equal each other. So this is all real numbers, infinite solutions. Or you can keep going, right? I want to move my x's over here. So I'm going to subtract 5x, subtract 5x. Negative 5. Oh, I'm sorry. Negative 5 equals negative 5. That is always true. If you wanted to keep going and put all your variables on that side, add 5, add 5, and you get 0 equals 0, right? So at this point, it was always true. At this point, it was always true. And at this point, it was always true. You could have stopped anywhere and said all real numbers. No matter what I put in for x, -5 will always be -5. No matter what I put in for x, 0 will always be 0. Okay? Just because you get 1 0 doesn't make it clear which one it is, right? If this side has a 0, but this side is not 0, it's no solution. If this side is 0, and this side is 0, it's all real numbers, but it might just be -5 equals -5. There's nothing wrong with stopping right there. This is also all real numbers. It's just anytime you have no x's, no variable. If it's a true statement, you can say that x could be anything. If it's a not true statement, that x can't be anything. There is no value for x. Good. All right. Moving on to 2.2. For 7 minutes. Might as well though, right? So just make sure you can do 2.1, all of the My Math Labs, and email me if you encounter any of them that were not something that we covered. Okay. Like, for example, this one, don't look at the answer. All right, solve the equation. 11 over 15x. I would rewrite that as 11x over 15 minus 1 over 5 equals 2. And then it looks like the other one with the example of 6 and 24. Okay, so you can always move that x up. That's the easiest way, I think, to do it. All right, writing and simplifying algebraic expressions and applying steps for problem solving. So, to solve problems, I don't even think this is a math lesson anymore. Understand the problem. Translate the problem into an equation. Here's the math. An equation must have an equal sign. Because if you're trying to solve a problem, you need an equal sign. Solve the equation and then interpret the results. So if you have a word problem and you made an equation, when you're looking at the equation you made, put it back into what they were talking about and see if it makes sense. And then what they were asking you to find, look back and say, is that the appropriate number of what they asked me to find? Good. That's all they're saying here. Just a little bit of an intro. All right. Example 1. Twice a number plus 3 is the same as the number minus 6. So here they call it a number, and here they call it the number. That's the same one. So this is like an English lesson at this point. A number introduces it, the number refers back to it, right? So those are going to be the same letter. Good. Twice, 2. So when I do these, I kind of like, if I'm doing them on paper, I go along and I write it. Twice a number right above the words or the phrase plus 3 is the same as the number minus 6. Okay, remember that rule that more than or less than means you flip these. Okay. So 10 more than x looks like x plus 10. But if it's not that phrase, you can just go in order. Twice, I'm going to put 2 first. A number, I'm going to put the letter next. Plus 3 is the same as the number minus 6. The product of means multiply. Twice a number and 3. And usually means plus, right? But we have this whole phrase. I don't want to do it in blue. I just did blue. The product of, that and goes with the product of, okay? We're taking the product of 2 things. So we're multiplying 2 things. The product of this and this, okay? So that means the product sign goes where the and was. If the and is out of nowhere, there's nothing in front of it, right? Twice a number and 3. Then you could say 2x plus 3. Twice a number and 3. However, the product of twice a number and 3 means the multiplication sign goes here. We're multiplying twice a number and 3 is the same as will be equal sign. The difference of, you don't need to flip anything around. It's not one of these, okay? It's not less than. The difference of, you keep it in order, but you're finding the difference. Think about the difference. The difference between my sister's age, I don't know, I'm guessing, and my age, I'm guessing, is, what is the difference? I should add them or I should subtract them, where there's a difference of 2 years. Good. The difference of 5 times the number and 3/4. Good. The difference of and. Okay. 5 times a number. 5 times the number is just like twice the number. Twice the number is 2x. 5 times the number is 5 times the number is 5x. And 3/4. We're not saying plus 3/4, we're saying the difference of. Good. Difference of is subtract. So I would say my final answer here would be 2x times 3, which is silly because the 2's are already being multiplied by the x, so that would actually be 6x if you wanted to simplify it, is 5x minus 3/4. Good. And then it's asking us to find the number. So you could now solve it. We have 1 minute. Okay, we're going to solve it. And then you can go if you need to go now early. If I go too long, you can go. All right. 2x times 3 equals 5x minus 3/4. 2x times 3, 2 times 3 becomes 6 with the x. 5x minus 3/4. So I'm just combining the terms here. Now we should always add or subtract before we multiply or divide, right? But first we want all the x's to the left. So I'm going to subtract 5x from both sides. 6x minus 5x is just x equals negative 3/4. Oh, that was easy. I thought we were going to have to divide. All right. And that is, I'm going to stop recording.